Hi, thanks for taking some time to watch our video today. Today we're going to be going over post-processed analysis of IQ data that's been captured on a Master Pro MS2090A. Now we know that customers have a lot of different options for how to analyze data. We're going to focus really on two different things. One is for customers who want to do their own tools. And then we also have worked with Bird Technologies to try to create or to be compatible with their Spectro-X tool. So we're going to show you an example of post-processing with that tool. So first with internal tools, basically our file format is given in our user guide. We come out in a DGZ and DGZM type file format. That the DGZM is your metadata files, and so anybody who's looking to process that data in a software package like a Python or MATLAB script, all that information is there in our user guide, and upon request we can even provide some starter scripts. So this is just a quick look at what that data looks like. These are some snippets from our user guide. All that information is there for you to look through. I'm going to spend a little more time in this video talking about the Spectro-X. Spectro-X allows you, it's actually a very powerful tool for post-processing data. It allows you to replay your IQ data in a much finer time resolution. You can basically take the data and manipulate it in any way you want to see more about what's happening with your signal. To illustrate this, I'm going to use this little pocket radar device that can be purchased off of Amazon. It's basically just a little speed radar. Easy for testing speeds like a baseball pitch or looking at traffic. It transmits a signal at 24.1333 gigahertz. But there's not a lot of mention in the specifications of the product about the modulation itself, the repetition bandwidth, which most users don't need. But if you're interested in digging into that kind of thing, then this is where you can use your spectrum analysis tools. So on a higher level, you can start with looking at the signal in a spectrum analyzer. So if you look at on the left, you can see some bursts. You can see this is a CW signal that's kind of tailing up in frequency over time. That gives you a little bit of an idea of what's happening, but you don't see a lot of the ins and outs of the signal. If you were to move out into a spectrum analyzer, which you see, or I'm sorry, a real-time spectrum analyzer, which you see on the right, you get a little more information in each burst. And if you see here the signal, there you're starting to see some data that's cropping up outside of the little intended band there, something that you weren't seeing in the regular spectrum analyzer. Now, it's good that you get more information from the RTSA, but you're not able to slow it down and really dig into it unless you're able to capture and look into the IQ. So what an IQ analyzer does is allows you to capture that data, take it in post-processing, and you can zoom into the fine details and start to see what's actually happening with that signal. So I'm going to show you what that looks like here. I've actually captured this signal ahead of time. And in order to play it back in Spectro-X, I need to convert it from our Anritsu DGZ format into the XStat format, which is read by Spectro-X. So they've provided a tool for us to do that. We basically pull in the file, it reads in the center frequency, sample rate, all that information. You click on this button, it will convert the file. And now you're ready to roll. You have that information in the XStat format. I close that, and I can now open up my my tools here for Spectro-X. I can play with my settings. If I want to look at this in the power range where I'm transmitting, I'm going to actually set my display range from -30 to -130. I'm going to adjust my my waterfall display so the colors are a little more interesting. Okay. And then I come in here, I select my input file, I browse through here, and let's see if I come into this file here, I get this information, my XStat file that was created. I can open that up. Again, it reads all of the information. I open it here, and then I can start to play it back. Now the data itself is going to play, this is spread out over a long time, so just to give you an illustration, I'm going to speed it up quite a bit here. So as I speed it up, you can see That's probably sped up a little too much. As I play it back, you can see here are those pulses that we were seeing in repetition, right? Now, what we can do, like you saw in the illustration, is if I come in and I can start to look at the finer details of this signal and zoom in a little bit, I can start to see, okay, at the end of the signal there's something happening. I can continue to zoom. Now what I'm seeing here is that as this signal is playing, right at the end we're seeing a little shift in frequency. Now that may or may not be intended, but it could be important to other communications that are in a similar band. So without being able to pull in this signal and really analyze it down to, you see here we're in the hundreds of microseconds in a sweep, I can really get a better feel for what's happening with the signal. So that's the power of using a post-processing tool to look at your data. So if I come back then to my presentation, the MS2090A is a fantastic tool for use in the field for capturing IQ data. It has premium RF specifications and full coverage up to 54 gigahertz. You can capture data as wide as 110 megahertz. And with the 2 gigabytes of dedicated internal memory, that gives you a lot of capture space. Configure it to meet your needs in different ways to capture or stream the data. You can save to a USB device, you can stream to a USB device, you can stream to Bird's IQC5000B, and then all sorts of different ways to set up your data. So thank you for taking time to watch our video. If you have any questions, please reach out to your local sales representative, and we look forward to hearing from you.